All right, so this is essentially going to be the domain of pre-fracturing. So we can just say pre-fracture right there. I'll make it red and cool. We could even do another one of these cool netbox things. Netboxes need to be fixed. I don't even know why I'm doing this. But anyway, we'll call this like initial properties. Or we'll call it maybe, yeah, that's fine. Some kind of property cool thing. Great. So there's our pre-fracture. Now, we're actually get to the fracture. And we're going to make our fractures based on what we say the fracture density is here. So I'm going to say, let's make a split. Split doesn't do much. A split is just a convenient way of doing the usual delete selected, delete not, or rather delete selected, delete non-selected thing that you usually do. But it looks cool. So that's what I'm all about. So here we go. So we'll say like, we have this attribute now, this cat fracture density. So let's just do that. Let's say if the fracture density, if there even is a fracture density, if it's greater, let's just say if it's greater than 0, then go to the left side. Looks like I didn't quite get it. Oh, so you can't actually do these spaces here, which is weird. So there we go. Everything that basically has a color is going to go to the left. And look, tragedy. Looks like all these chairs made it into the rotor assembly thing up here. So let's go back to rotor assembly for a second. Select them. It looks like, yeah, so there they are. We could do a thing like that. I'm just going to do this. I'm just going to say control, drag out everything that's here, press enter. Cool. Oh, okay. So now when I get down here, good. So those are gone. You gotta turn this off too. So we've got our split here that's going to everything. When we look at the split, it's showing us essentially what this output is, not with the right side. And to prove that, if I put a null here, you can see that surely is left side. If I put it here, this is everything else. So this is everything where all the pieces will be considered individually. I'm going to press 9 to turn that thing off. So all these pieces will act on their own in the meantime. Great. I would actually say, and this is again a great reason why we have this kind of setup, I want to add this part to the front. So I definitely going to want to have, I'm definitely going to want to have this panel in the front. So I'll just shift click that in there. Great. So he's included in that too. So everything on the left here is going to go to some kind of fracturing thing. And in fact, what we're going to want it to do is fracture each thing in a for each loop. So we'll say, hook this up to here, and we'll say, hey, you don't even need to do it based on the name. You can just do it per primitive. Because each primitive, of course, each point is the same as the primitive, is the same as the vertices, the same as the packed alembics when you're dealing with packed anything. So this thing we have 88 on this side apparently, and we're gonna say this does 88 iterations, so we know it's working correctly. But immediately I'm like, wait a minute, this rotor assembly, we wanted that grouped because we want to rotate this thing later. But I already know I don't want this to actually be fractured. So I'm going to set that to 0. See how it got removed immediately? I can't stress this enough. This is why it's important to have quick and easy workflows. So we also don't want to fracture the rear rotors. They're just too small already. We don't need to waste our time with that. They're already going to fall apart in a cool way. It's just made out of so many pieces already. We can mangle them later arbitrarily, but as a fracture, they're already pretty small. So don't waste our time. So now, what do we got? We got like 34 things. Okay. So then we see it's going to do it 34 times. where each iteration is going to work on one of these things. I like to do this here. Single pass is used for debugging. And what I like to do is put a $F here, which is the frame number. So now, as I scroll through, I can see each of the different for loop iterations. That's like a fun little trick. So we can just debug individual things. Like if this is giving us problems, I can say like, well, what's the problem in here? When we're not debugging, we just turn this back off, and it's doing all of them. So I'm going to say merge the ones that we don't fracture with the ones that we fracture, so we get back to one big happy family again. Okay, so let's actually set up the fracturing thing here though. So I'm going to say, so by going here, we'll just see whatever the last iteration was. And this is as good as anything, as any piece to test on. So I'm just going to move this down here. So what do we need to do? This is going to be like a normal Voronoi fracture kind of deal. Right now though, it's packed, and that's not going to help us. So what we need to do is, let's unpack it to actually get into actual polygon land. Now you'll see it's actually a polygon soup where it's one primitive. So it's not, there's not a primitive per face, it's just one primitive. That can work. It's been my experience that it causes the Voronoi fracture to choke sometimes. So let's convert it into just straight up a polygon per face. See how I'm able to select each one, whereas when I was here, the whole thing was one. So anyway, so it is now, oops, that. We'll do a regular kind of, let's just scatter pieces around it. I'm going to say, don't force it. Let's use a density instead. The density is going to be what we tie to our density up here with the cat fracture density. So no reason to have this at 10. Let's just start it with 1. There we go. And we already know, thinking ahead, that we're going to multiply this times that cat fracture density. But let's just finish the rest of the setup here first. Oops. Drop a Voronoi fracture down, and you'll see that the for loop will keep, like this orange thing will encompass the nodes that we put into it. So you don't have to like stretch it out yourself for anything. So the points are, of course, this. And as you can see, if I were to visualize pieces, there they are. It's all smashed up based on those points. Very cool. We're going to want to assemble them back into packed things once it's done, like so. So now we're back. We have 5 pieces. We started with 1 piece, of course, when we came in, and now we broke it up apparently into 5 pieces. We can say, we can do this. We can say, let's copy whatever attributes we had on it on the original piece to this one. So we'll just point this all the way back up to here. In our case, we mostly just want the color, but we might need some other things. We'll want the cat name also. Now, because we're copying from one thing to 5 things, it's just going to copy this, whatever it found on the one thing, to all 5 pieces. In this case, that's the color. Let's see. Do we have our cat name? See right here, it just says CD. So we're going to want to say cat anything we came up with. And we're also actually going to want to have the original path. So we have the category name. So all the new pieces are our top rotors, which is true. We have the path, but now each new piece has the same path. So that's a little problematic. Let's fix that. Let's make a primitive wrangler and say, let's start with that, but let's just refine it a little bit. So you could say something like the path is going to be sprintf. This is just a vex command for just playing with strings. And I'm going to say %s is going to be replaced by some string. Underscore piece will be literally that. And the %d will be replaced by some number. So what are we going to put here? Well, we're going to want to put the path as it is right now. The one, because all the pieces have the same path right now. And then we're going to say, so the path that it came from, essentially, the path of the original piece, underscore piece 1, 2, 3, 4, 5, or whatever. So I'm just going to say primnum. So now, if I look at this, you'll see it is the original path, rubber A4. Now it's going to be rubber A4, piece 0, piece 1, piece 2, piece 3, piece 4. So now, once we export this later, it'll put it back into the same hierarchy that we expect, where these things came before it. But now they have this subfracture piece business. So I'll call this like repath or something cool like that. And that is what's going to be the output here. So now I'm going to say, now it's going to do this for every node, or rather it's going to do it for every incoming thing that we ask it to fracture. You can see it doing it down here. Some pieces might take longer than others, but essentially there we go. And you can see the fracture lines in there. I'm going to say like exploded view like this, and you can see it is indeed broken up. And in this case, it merged the fractured pieces with the unfractured pieces, the ones that we decided not to fracture. So now we have a helicopter that apparently is 602 pieces. 361 of them are still the alembic ones that it came in as, packed, and 241 are these new fractured pieces. For our purposes, we'll treat these essentially the same, but I would say that looking ahead, we're going to want to convert these alembics into packed fragments. We're not going to actually fracture them, but we're just going to essentially change the data type. But we'll get to that a little bit later in this chapter.